Hello everyone. Welcome to my YouTube channel JanaAI. So in my NLP tutorial first, in the first episode I've discussed about NLP overview. What is natural language processing? How can our human language can communicate with computers? Then we have discussed about different types of language building block like syntax, semantics, lexemes, morphemes. Then we have discussed about parts of speech, tagging, named entity recognition. Then we have discussed about different types of vectorization techniques like word embedding and all. Okay. So in this tutorial, we will discuss about NLP project pipeline. To create a project, what are the pipelining? How we'll implement a project? So first topics is your problem identification and scope. So first we'll discuss about what is the problem definition. I mean, which type of use cases we'll use. Is it like a text summarization? We have to identify the problem. Is it like a text summarization or question answering or chatbot preparation or like say translation program problem? So we have to identify the problem. So based on the problem, we have to collect the data sets. Okay, collect the data and prepare the data. Once the data has been collected, we'll do the pre-processing of the data and the tokenization of the data. Okay. So once the data preprocessing and tokenization done, then we'll represent the data by text representation techniques. Once your data has been prepared, then we'll do the select the model. There are different types of machine learning model as well as your deep learning model. Then we'll select the based on our use cases, what use cases we have identified. Based on this use cases, we'll select the model and model architecture also. Once the model has been selected, we'll train the model. Once the model has been trained on the training data, we'll evaluate the model based on that testing data set. If and then we'll validate some metrics, accuracy metrics like your accuracy metrics or performance metrics or configuration metrics, whatever it is there in. Then based on the metrics, if you are not satisfied, then we'll do the some hyperparameter tuning based on your grid search CV and all. So once the model has been evaluated and validation has been completed, then we'll do the deployment. Okay. So these are all overview of NLP project pipelining. Okay. So let's discuss one by one. So first is your data collection and preparation. We'll collect the relevant data for training and evaluation. This data could be include text corpora or label data set or the domain specific documents. Okay, this data can be your text corpus or your label data sets or can be your domain specific any documents. You have to collect the data. Once the data has been collected, then we will clean and pre-process the data to remove the noise in your data set. If there is any something missing value or let's say null value, we have to remove those things. We have to remove the noise of the data and correct the errors and the standardize the formatting of the data. Okay, once that data has been cleaned and pre-processed, then we will do the split the data into your training and the validation and the testing sets to evaluate the model performance. So that is the overview of your data collection and data pre-processing. Then we'll start about text pre-processing. So once your as we have discussed about NLP based architecture, so NLP is generally worked on textual data. So once we are getting the textual data, means like a paragraph or a sentence, then we'll split the sentence or the paragraphs in a different split the text into a words or subwords. So these words or subwords or units is called the tokens. Okay, first it is tokenization. Then we'll once the tokenization has been completed, then we'll do the lowercasing, convert all the text into a lowercase to a standard size of the data. Once tokenization has been complete, then we'll lowercase that token word. Okay, tokenized word. After that, we'll remove some stop words like suppose I'm telling you that the sun has rise in the sky and here the in these are the stop words. Okay, these stop words you have to remove. Okay, remove the common and non-informative words which are not useful. Okay, useful in your most of the NLP cases. So this type of stop words we have to remove. Then we'll do the lemmatization and stemming. So in my previous tutorial, NLP tutorial, I have discussed about broadly about your lemmatization and your stemming to reduce what this lemmatization and stemming does. It will just reduce the words to their base form. So let's say I have three different forms of runs, running, run like that. Then we have to convert these three different forms from your token data set to a single form, okay, like run like that. Okay, this lemmatization and stemming can algorithm can reduce the words to the base form. Once the lemmatization and stemming activity has been completed, then we'll do the removing the punctuation. So in your data set, you know that there is some dot, comma, this type of punctuation we have to eliminate. After that, we have to handle the special character. There are some special character like hash, at the rate, okay, percentage. So you have to handle this special character by regular expression. So these are the text preprocessing tasks before your model training and evaluation selection. So you have to preprocess our text, okay, data. Then we will do the text representation, okay. Once the data has been tokenized, after that we will take a tokenized text into a numerical vector. Okay. So as you know, the computer can understand only the binary or the numerical data. So computer cannot understand your language data, right? Natural language data, text data. Okay. So you have to convert those data into a numerical form or vector forms. Okay. So this is your text representation forms, vectors form in the machine learning model so that machine learning models can process your data. Okay. So there are different types of techniques like bag of words, TF-IDF, OR embedding. So these are the techniques to convert your textual data into your numerical data, numerical vectors. What to vector, growth, and the contextual embedding like BART and GPT. These are the text representation from this. In this techniques only, we can do the tokenized text into a vector. Okay. And the last is your decide which representation suits your task and data characteristics basis. So, well, as per your task and the data characteristics, you can use any of the embedding techniques. Okay, or that you can use bag of words or TF-IDF or embedding. Okay. So this is the text representation techniques. Now we'll select once your data has been finalized, when your textual data has been converted from your text to after the tokenization, your data has been converted from text to numeric or in a vector in a multi-dimensional space or a continuous space. Then we'll once your data has been ready in the numerical structure in a numerical vector, then we'll select the model. Okay. So there are different types of model. Choose an appropriate machine learning or deep learning model. In machine learning model, there are some machine learning model like classification, let's say logistic regression, support vector machine, and then your the probability based theorem algorithm like net based theorem, random forest, decision tree, execute database. There are ensemble techniques. There are a lot of machine learning problem is there which are used in your NLP use cases. Okay, based on your use cases, you can use those machine learning models. If the NLP task is very much complex, right, that you are doing something, text summarization, question answering, okay, language translation. So this type of use cases, your normal machine learning models cannot handle this type of use cases. Okay, there are a lot of complexity in the in their test. So at that time, you have to choose any deep learning based algorithm like that your convolutional neural network or recurrent neural network. LSTM means long term long short term memory, or you can use any transformer based architecture, okay, model like GPT and all. From Hugging Face also there are transformer based so many models is there. You can use attention based model or you can use auto encoder decoder. This type of models you can use in your NLP task. Okay. Then you will decide whether to build from the scratch or pretend the models to for the transfer learning. After that, you will modify or adapt the existing architecture as per needed. If you can adopt or modify your existing architecture if it is needed. Okay. So this is the phase of model selection and the architecture. Now we'll discuss about model training. So after selecting the model, suppose let's say you are selecting any machine learning model, like say you have selected an based classification for your spam detection use cases. Okay, then what you will do, whatever the data set you got, let's say in your spam data set, you are getting, suppose let's say 100 of spam and 200 of ham data. So then you will split those data, into a training and validation and testing set. Okay, then what you will do, you have to train your selected model on the training data. So once your model has been, once your data set has been divided into your training and the testing phase, then you will train your model with your training data. Okay. Use the validation data to tune the hyperparameter and prevent the overfitting. To prevent the overfitting, use the validation data, okay, for hyperparameter tuning. Okay. Then use the training data to update the model words through the iterative optimization gradient descent. Okay, so you can use the updating words in your neural networks through the iterative optimization. If you are after training, if you are getting a wrong score, like the F1 score or whatever the score you are getting, accuracy score, then you can iteratively you can training again, and you can update the weights according by the back propagation technique. You can updating weights and all. So it will be like a iterative models until your training data you will get the correct output. Okay, then we'll do the performance based on the validation data using the appropriate metrics like accuracy metrics, or the for deep learning algorithm and deep learning techniques you can use the precision recall, that like the two positive two negative F1 score you can calculate, and you can evaluate your model. Okay, based on your validation data. After that, in your suppose let's say if you are using any GPT based model, there we can do your model evaluation by doing the fine tuning. Okay, in the fine tuning you can train your model. Okay, fine tune your hyperparameters to improve the performance, learning rate, improve the performance. You can by doing this hyperparameter, not like the learning rate. Okay, or batch sizes, how many batch sizes you are giving, regularization things. There are so many different type of hyperparameters are there. You can by changing these hyperparameters, by changing this parameter value, you can tune your model, okay, to improve your performance. Then consider techniques like grid search. This is the most famous technique, the grid search cb algorithm, cb techniques, or random search for the hyperparameter optimization. Okay, you can use the grid search cb for your hyperparameter tuning. So this is the step where you can evaluate your model, and you can hyperparameter of your you can tune your hyperparameter to improve your performance. So in this topics, we'll in this phase of NLP project planning, we'll discuss about the model validation and testing. So assess the final model's performance once your model has been training has been completed, and you have done the hyperparameter tuning of the training data set, and once the final model performance of the testing data set to ensure the generalized as well as the newer answer data. So once the model has been trained, then you are fitting that data in your testing data set, and once you will you predict the output. Okay, so if your prediction is good based on your testing data set, to ensure their newer unseen data, whenever the new data will come, then it will try to predict. If the prediction is good, then if your accuracy is good, and if everything is good, then you can take this model, okay, for the deployment purpose. Okay, perform the error analysis to understand the type of mistake in the model makes. So you can, there are some error matrices that like r square, adjustment, r squares, to perform any error is there in those in the model. Okay, so this is your model validation and the testing testing phase. Okay, so once the validation and the testing has been completed, your model has been ready. Okay, then we will do the deployment. So there are a lot of deployment service provider is there in the cloud. There are some cloud deployment like say Azure, Microsoft Azure, AWS. For ML project, there is AWS SageMaker is there. AWS Databricks also there. SageMaker providing your end-to-end ML of solutions. Okay, so you can deploy those your model in your AWS SageMaker or AWS Databricks, or you say Azure machine learning services is there in Google also, Google Cloud, Google Colab. Anywhere you can deploy your model You can create your API, or you can create your NLP applications, class-based application, whatever it is. You can deploy those model in the cloud, any of the cloud service provider. Okay, and ensure the deployment in Preposseing can handle expected user loads and requests. So once you deploy your model, so ensure that your your application is able to handle the all the users load and the request, whatever the request is coming, whatever the traffics are coming. So be ensure that your application should handle those type of loads and traffics. Okay, request. And after that, once the deployment has been completed in your cloud production environment, then you have to do the monitoring. So you have to do the continuously monitor the deployed models performance and the user interaction. So there in Amazon AWS, there are cloud watch, cloud monitor. There are a lot of services is there, so that you can monitor your application. Okay, end-to-end application. What are the traffic? What is this load? What is the CPU utilization? What are the memory utilizations? And so many things is there. Parameters is there for your model, for your NLP applications, what you have deployed in the production. So you can implement the mechanisms to detect model drift or degradations over time and trigger the retraining as needed. So once the over a time, once you are getting the new data and you are training and you are redeploying again in there. So this is the iterative process. You know that the DCI/CD pipelining is there, DevOps pipelining is there. Your new data will come. You will train on those new data and will validate the your existing model with the other model. So if your new model is getting better output, better accuracy, then you have to replace those model. So trigger the retraining as needed. So that will be depend upon your performance. Okay. So this is the task to implement the mechanisms to detect the model drift or degradation over the time and trigger the returning the model. Okay. Then we will collect the user feedback and use of its inform the further improvements. So once your model has been raw material, you are, and once the user is using this model, so you will take the user feedback, and based on the feedback only, you have to return your model or further improvements of your model. Okay. So these are the optional things that if you want to user if the user base is high, no, then you have to create your web application or mobile app or chatbot like type of interfaces for. If you want, then you can create this type of web applications or mobile applications for your NLP use cases, whatever you are creating. And the scale and optimization, like that, if the user if your user data is high or if your traffic is getting high, then you have to do the auto scaling. Okay, scalability to handle the increasing user demands. So once you have deployed your application into the production, once it is running your OCI or Azure or AWS, wherever it the cloud providers, many cloud providers are doing the auto scaling capability. Okay, you have to auto scale. You can use the techniques like load balancing, caching mechanism, like that. Amazon Edge is also there the content like caching mechanism. There are a lot of techniques is there for their availability and data backups. All the cloud service providers are providing the same, so you have to handle those type of scaling and optimization mechanisms all for your NLP projects. So this is the overall pipelining of to create your NLP project, like from your identifying the problem and the definition to data collect, then data pre-processing. After the data pre-processing is done, then you are representing your data. You are kind of converting your textual data into your multi-dimensional vector space. After the data has been ready, then you are selecting the model, and you are based on your use cases, you are selecting machine learning or say deep learning models, and then you are splitting those data into training and testing spaces. After that, you are training those model, and after that, you are validating the data based on the testing data set. Only you are predicting the output and all. Once the model has been ready, then you are doing the hyperparameter tunings and all. On the testing has been completed, then you are deploying in the production. Okay, any of the cloud service provider or your own premises server yourself. So these are all the NLP project pipeline. How we are end to end create the project. So this is the deployment pipeline. Okay, create project pipelining. So in the next lecture, we'll discuss about the different types of NLP algorithms, different types of embedding techniques. Okay, I mean, different types of NLP deep learning algorithm, transformer, recurrent neural network, and so on in details. And we'll do a hands-on project. Okay, so thank you very much. Thank you for watching this video. So please subscribe my channel to a friend or family. Okay, so if you want to learn more about this NLP, the natural language processing, you can You can visit to my website, to our website, that is https://janai.com. The link is there in the video description. You can watch it was there. Okay. So thank you. See you in the next lecture.